할로.
나 사진 찍어줄 사람.
Can you hear me? If you can show me the circle like this. I'm Jung Hyun and I teach PLC and electronic theory at Hydrogen Energy High School. So, it's my first time to teach someone who's speaking. Before we start the class, we have a small game. Let's begin our class. I will explain the basic of PLC. PLC is a short word for programmable logic controller. In Korea, we call it PLC, but I heard in Germany, you say SPS.
Hello, German student. Give me the student who will open the first chapter of the international exchange class. First of all, I would like to thank all the students and teachers who participated in this class with us. Our Hydrogen Energy High School is a school that revives to educate students based on hydrogen, which is an eco-friendly energy, and to grow into talented people in the future industry. This picture is of us participating in this class. So let's listen to the first announcement of Kyung Jae-hoon and Lee Jin-soo of Hydrogen Energy High School.
Hello, my name is Jins and to create a normal open contact, press F3 and enter PB1 as the device name. A normally closed contact that breaks the circuit when activated. This is A contact. This is B contact. Bye bye.
Hello, my name is Kim Won-yo.
I will click PB1 and set it as an A contact. I will set PB2 as a B contact. The device for PB1 will be P0A, and the device for PB2 will be P0B, and the signal will be set to M0, and M0 signal will control YL and GL. This is A contact. When you press the A contact point, the signal enters M0. This is PB1 and this is PB2. I will press the PB1 and turn on yellow lamp and green lamp, and I will press the PB2 and turn off green lamp and yellow lamp.
This is effective.
Hello, my name is Jeong-gun
and Myung-soo.
We are going to explain how to use a self-holding circuit to turn green, red, and yellow lamps on and off. First, this is PB1 and this is PB4. This is B contact point. This is a self-holding circuit. He is making a green lamp. This is yellow lamp PB3. When you press PB1, the M0 coil is energized, creating a self-holding circuit. Then the green lamp turns on. When you press PB2, the yellow lamp turns on. When you press PB3, the red lamp turns on. Finally, when you press PB4, all the lamps turned off. I will show the VMT. Press PB1, the green lamp turns on, and PB2, and the yellow lamp turns on, and PB3, the red lamp turns on. Finally, you press PB4, all the lamps turned off. Since the PB4 switch is configured as a normally closed contact, it cuts our signal. That's all. Thank you for listening our presentation. Finish.
Thank you.
Hello, we are Park Si-hyun.
And Moon Yujin from Hydrogen Energy High School. We would like to explain the automation process kit to you.
The automation process, kit known as a modular production system, consists of supply cylinder, drill cylinder, forward cylinder, and eject cylinder, and three inductor lamps, control switches, and a conveyor.
We call this cylinder supply cylinder. A supply cylinder serves to move things to where they are to be processed. We call this cylinder forward cylinder. A forward cylinder is used. Sorry. We call this cylinder drill cylinder. A drill cylinder is used to process transferred objects. We call this cylinder forward cylinder. A forward cylinder transfers processed objects to a conveyor. We call this cylinder eject cylinder. The eject cylinder is used to distinguish and discharge defective products, metals and non-metals from objects moving by conveyor.
The indicator light is available in three standard colors: red and green and yellow. Three a total of four control switches used to send or block control signals. Transporting products, those conveyors are responsible for transporting products for automated process. Thank you for listening.
Hello everyone. Before I begin, I'd like to briefly explain what we'll be learning today. We are going to learn how four different cylinders, the supply, drill, forward, and eject cylinders. Also, I apologize in advance if the materials or visuals are a bit hard to see. Now let me explain how each cylinder works and how they are connected in the process. The supply cylinder moves raw materials such as small parts or blocks from a storage area to the processing position. When activated, it pushes the material into place. After that, the cylinder retracts and gets ready for the next material. This is the first step in the process. Next is the drill cylinder. Once the material is in place, the drill cylinder moves the drill down to create a hole or perform machining on the material. When the drilling is complete, it moves back up. This cylinder plays a key role in shaping or modifying the product. After that, the forward cylinder comes into action. Its job is to move the processed material forward to the next stage. It pushes the material out of the working area so that a new piece can be placed. Once the material has moved, the forward cylinder returns to its original position. Finally, the eject cylinder completes the process. When the product reaches the final stage, the eject cylinder pushes it out of the system, usually into a collection tray or container. This step clears the way for the next cycle and marks the end of the automated squad.
Now let me explain the lamps, the switch, and the conveyor in detail. First, red lamps. The red lamp turns on when there is an emergency or a serious error. It means the machine must stop immediately. Operators need to check and fix the problem before restarting the system. Second, the yellow lamps lights up when there is a warning or a minor issue. It means the system is still working, but something should be checked soon. This helps prevent bigger problems. Third, the green lamp is on when the system is operating normally. It shows that everything is running smoothly. This is the default state after starting the machine. Next, switch. The switch is used to start or stop the automation system. When we press the switch, the system powers on and the green lamp lights up. If there's a problem, we can also use the switch to reset the system. Finally, the conveyor. Conveyor moves products from one point to another automatically. It starts working when the system is on. The conveyor stops if there is a red light or emergency situation. Thank you for listening.
Hi, my name is Kim Byung-eun and I go to Hydrogen Energy High School. I will explain from M1 to M4. When the signal enters M1, the three cylinder moves forward. When completed, the forward cylinder moves forward, and when it is completed, the eject cylinder moves forward and the green light turn on 2 seconds after completion. Thank you for listening.
Hello, we are Kim Ye-in and Kim Tae-ri from Hydrogen Energy High School. Today we'll be explaining the cylinder machining process from steps 5 to steps 9. At steps 5, both the discharged cylinder and the ejection cylinder move to the retracted position. Following at step 5, both the discharge cylinder and the ejection cylinder move to the retracted position. Following this, at step 5, the processing cylinder also retracts. At step 7, the supply cylinder extends, and the yellow lamp turns on to indicate this action. Then at step 8, the supply cylinder retracts. Finally, at step 9, the yellow lamp turns off. Thank you for listening.
Actually, our school curriculum focuses on PLC, you call SPS probably. But because of that, we have a lot of certification related to PLC. I'd like to show you one of the most important certificate in Korea. I will show you a part of a PLC section from this certificate. I will explain briefly or roughly. Our student will show you how to solve this task. First step, when I press the PB1 switch, which is a start switch, first step is 3-cylinder move forward. After that, eject cylinder move forward. After that, 4-cylinder move forward. After final step is finished, everything reset. When you press the PB1 switch again, you can start over. So each our student will show you how to solve the task. For now, our student turn.
Hello, my name is Kim So-yeon. What we are going to introduce is a self-holding circuit. Let me show you how I made the circuit. This is PB1, PB2, PB3.
The green lamp turns, but when you let go, the green lamp turns off. That wasn't very convenient, so I added PB2. When you press PB2, the yellow lamp turns on. Even if you stop pressing, the yellow lamp stays on. Press PB3 to turn off yellow lamp. This type of circuit is called a self-holding circuit.
At M1, the processing cylinder moves forward. At M2, the processing cylinder moves backward and discharge cylinder moves backward. At M3, the transmachine cylinder moves forward and the discharge cylinder moves forward. Now I will and explain the ladder diagram myself. M0부터 잘. M0 use PB1 to sign signal and cut off all signals. Use M9 as a B contact at and M1 full coil and magnetic holding circuit. In M1, machining cylinder moves backward, so use LS3 and right M0 prevent the back motion from running fast, and right M1 for the coil and self-holding circuit. In M2, we use limit switch 4 because machining cylinder moves forward. We use limit switch 7 because exhaust cylinder moves backward. We use M1 so that the backside movement does not work first, and we use M2 for the coil and self-holding circuit. On the M3, the transmission cylinder moves backward, so use limit switch 5. Okay. On the M3, the transmission cylinder moves backward, so use limit switch 5, and the discharge cylinder moves forward, use limit switch 8. Use M2 and use M3 on the coil and self-holding circuit to prevent the real operation from operating first.
Hello, my name is Liu Chan, and today I will explain what happens in M4 and M5. In M4, the forward cylinder moves forward and the timer activates. In M4, the forward cylinder moves forward and the timer is activated to pause the process for 2 seconds. After that, the green lamp turns on. In M5, both the forward cylinder and the eject cylinder move forward, then the green lamp turns off. In M4, limit switch 6 is used to indicate that the forward cylinder has moved forward. To prevent this action from occurring before the previous step, M3 is placed next to it. A timer is also added to stop the process for 2 seconds. Okay. M4 is used for both the coil and the self-holding circuit. In M5, the forward cylinder moves forward, activating limit switch 6, and the eject cylinder moves forward, which is indicated by limit switch 8. Timer T1 is added to prevent M5 from receiving a signal during the 2-second pause in M4. M4 is also used to ensure that M5 does not activate before the preceding action. M5 is used for both the coil and the self-holding circuit. Thank you for listening to my presentation.
Hello, but I will explain the ladder diagram from M to M7 and then I will write it out as a circle. In M6, when the drill cylinder tries to retract and forward cylinder and the eject cylinder have completed their retract. In step 7, when the supply cylinder is preparing to extend, the drill cylinder has completed its retraction. That is the yellow lamp turn on. Now let's move on the circuit and explain white line. The previous girl works up to M5. First write limit switch S4 as A contact, and then write S5 and That's 7. Also as N5. N5 is the previous write N5 and write it within the circuit. For the output part, ladder embed M6 and then write M6 again as a self-printing circuit. For the next write L7 and L3 and L1 and then use the previous write N6 as a preceding contact in the circuit. For the output part level embed M7, then write M7 again as a self-holding circuit. Finally, use M7 as a contact and write yellow ramp in the output part. Thank you so much.
Hello guys, my name is Choi Jung-ho.
한규.
In this image, Empire causes the supply cylinder to extend. Then, moving the radar diagram, we write limit switch LS2, which indicates the extension of the cylinder. Next to it, we write M7 to prevent M8 from being activated before the previous operation. In the coil section, we write Empire, and below that, we connect the self-holding circuit, where we write M8 in the self-holding circuit. Thank you.
Now going to back to the previous image, let me explain what M9 does. M9 causes the supply cylinder to retract and the yellow ramp turns off. Then back in the ladder diagram, we write limit switch LS1, which indicates the retraction of the cylinder. Next to it, we write MA to prevent M9 from being activated before the prior operation is complete. In the coil section, we write M9 and below that we connect the self-holding circuit, where we write M9 in the self-holding circuit and in the circuit at the top, M9 is used as a normally closed contact to reset the circuit. From here, someone else will continue the explanation. Thank you for listening to our explanation.
Hi guys, my name is Kim Jae-won and I will tell you about the output of the cylinder now on. First of all, the supply cylinder is explained. The supply cylinder moves forward when the signal is turned on at M7. And the supply cylinder moves backward when the signal is cut off at M8. M7 and cut off at M8. Supply cylinder moves forward, and I will tell you is SOR 1 and again from the M8 and the supply cylinder moves backward. M8 is SOR 2. Secondly, I explained the drill cylinder. The drill cylinder is signal. Drill cylinder is signal on the M1. And the drill cylinder is a moves forward and signal cut off on the M6. So the drill cylinder moves backward, moves forward, M1 moves forward, M6, and this SOR 3. Third, I explained the forward cylinder. Forward cylinder turn on the signal at M3. Signal on M3 and moves forward, and signal cut off and moves backward as a M5. M3. Oh, 정말. M3 and cut off and backward M5 and so forth. Fourthly, eject cylinder is a moves forward as a M2 signal on moves forward M2 and signal cut off as a moves backward as a M5 forward M2 move backward M5 and so 5. Next, the output of the yellow lamp. The explain yellow lamp has a turn on the M7 and turn off has a M9 turn on yellow lamp turn on M7 turn off M9 and yellow lamp is the second device name is YM. And finally, I will explain the green lamp and finish the presentation of the output part. The green lamp has a turn on the M4 and turn off the M5. The M5 turn on M4 turn off the M5. The device name is GL. Okay, thank you for listening to my presentation. Thank you.
Hello, my name is Hyunwoo. I'm going to learn VAMT using the finer programmed circuit made by my previous teammates. First, I will press the PB1 switch, then the 3-cylinder move forward. First, I will press the PB1 switch, then the 3-cylinder move forward, then the discharge cylinder move forward. After that, when the forward cylinder move forward, the green lamp turns on for 2 seconds and then turns off. Next, the eject cylinder rejects. After that, the supply cylinder move forward, and at that time, the yellow lamp turns on. Then when the supply cylinder retracts, the yellow lamp turns off. Let's see that. Thank you for listening.
Hello, I'm Kim Miso, who will give you the final assignment. After Maghan's presentation, our presentation is finished. The final task I will give you is to divide the redodo we have presented so far into Korean and your Germany, and divide the circuit from M0 to M4, M5 to M9. You can hand draw the M5 to M9 on the XG program paper that we will hand out to you and send it to us. If you send us your own drawing circuit, we will merge them with our own drawing circuit and learn the simulation. We will record the simulation video and send it to you, and I will send you the details by email. I hope you will do your best to carry out the assignments we gave you. Let's meet in Germany in 2 months in July. Take care until then. Ciao.
It's done. It's over. Thanks for listening our explanation. It finished earlier than I thought. Probably my students feel relaxed than last week. Thanks for listening our explanation first. And
하십시오.
예. Hi guys. I'm Jaewon. I want to go Germany, but I can't. But we meet to see you again. I love you guys.
Thank you.
We look forward to seeing you.